One of the things that we'll be doing as we do inner products of vectors in Rn will be some computations that are rather involved in creating a different basis for Rn, depending on what vectors we're given. So I wanted to show you a couple of things that you can do on your calculator that'll help you do inner products, dot products of vectors that are in Rn. And we use the list commands to help us do this. So anytime you enter anything in braces and then separate them by commas, so say it's 4, 3, 9, and I put that in braces, that creates what's referred to as a list. So notice it just separates it like it separates elements in a matrix, but we can treat these lists like they're vectors. So if I wanted to do a dot product of two vectors, say I wanted to take this 4, 3, 9, and I wanted to take the dot product of it with, say, -2, 1, 8, the first thing I could do, oops, I need to make that a brace, not a parenthesis. The first thing I could do is multiply the entries together, because that's what I need to do when I take a dot product. So notice what this particular operation did. It took the 4 times the -2, made the -8. Took the 3 times the 1, made the 3. 9 times 8, 72. So when you multiply two lists together, as long as they have the same length, same number of elements in them, it will just multiply corresponding entries. Now, of course, when we do a dot product, we want to add these things up. So there's a command in your TIs that will let you add these up. So I'm going to go to second list, and I'm going to arrow over to the math. And notice number 5 there, right here, says sum. So if you use the sum command, it'll add up all of the elements that are in your list. There's obviously some other things in there too, but all we're going to care about for right now is the sum. So I'm going to hit number 5 to get the sum. And then I want to sum up the elements that are in the list up in that previous answer. So I'll use second answer to get to that. And it adds it together. So that gives you your dot product. Now, of course, you could do this all at once. I did it in several steps, but you could do this all at once. You could go into second list and hit sum, and then you can type in your two lists. So 4, 3, 9, and end your braces, times, and the other one was -2, comma 1, comma, oops, missed my comma, 1, 8. I can end the brace, parenthesis, and I get my 67. So I can do it all at once. Now, you can also do other vector operations with this. One of the things that we're going to want to do is do scalar multiples. So if you want to do a scalar multiple, that's pretty easy, because I just need to take, say, a 2 times, and then I could do the list, say 4, 3, 9. And notice it just takes the 2 and runs it through the list, just like it would do a scalar multiple of a matrix. So scalar multiplication is one of the things we want to do. You could add two lists together. It'll do the same thing. If I wanted to do the 4, 3, 9, and add the 2, or -2, I guess I had, -2, 1, 8. It'll add them component-wise again, just like you would want them to. These are things that we're going to want to do with these lists, with these vectors, when we talk about what's referred to as the Gram-Schmidt orthogonalization process. Now, you've probably noticed as I'm typing these things along that there's a lot of tedious work of me typing all these things in. So one of the things that you might want to do is actually store your lists and then just refer to them by their names. Notice that above 1, 2, 3, 4, 5, 6, there's L1, L2, L3, and so on. Or if you noticed when I went up here, it has names of your lists, L1 through L6 here. I don't know why it has A and B in here, because I tried to store things as A and B earlier and it wouldn't let me. So I don't know why I did that. But anyway, these are predefined variables that allows you to store lists in. So to store something in one of those, you would type in your list. So we'll just do the first one here, 4, 3, 9. And then I use the store button, which is over there by the number 1 right here. Use the store button and then do second L1. And now it's stored in memory. It's stored in L1 for use later. As a matter of fact, if I just hit second L1, it'll spit it back out at me. And you can do your list commands like we did earlier on that variable. So if I do sum of L1, it'll tell me 16 when it adds those components together. This is also going to be very helpful in your calculations when we do that Gram-Schmidt process that I talked to you about earlier. Actually, I just gave you the name of it, but it's going to be very, very helpful to be able to store these things because it's computationally expensive to be able to do this process. So I want to give you a little bit of a faster way to do it, at least when you have the normal Euclidean dot product to be able to do it. So we'll talk more about this when we're talking about it in class, but I just wanted to let you know that this was an option for you to be able to do these vector operations without having to work so hard by doing them all by hand and without having to learn a new computer program to do it.